Today we discuss a domain-driven design trilemma. Is it possible to have a domain model that is complete, pure, and highly performant? Let's discover it in the next few minutes. This video was inspired by a comment that pointed me to an excellent blog post by Vladimir Khorikov. Domain model purity versus domain model completeness. Vladimir did a perfect job at highlighting all the competing forces that developers face when they try to convert a domain model they design into actual code. He believes that we cannot have the three characteristics we just described: purity, completeness, and performance. We need to sacrifice at least one characteristic. In his conclusion, he suggests a way forward I have some serious concern about. So, watch the video to get my side of the story. Let's start by defining completeness. A model is complete if it contains all the application domain logic. The opposite of a complete model is a fragmented model. Imagine we need to support username updates in a user management system. We have just few simple rules. The username must be alphanumeric, more than 8 characters, and less than 24 characters. If we want to keep our model complete, we need to slot this logic in the domain layer. In this case, it would be the user entity class. As you can see, we implemented the requested logic in the update username method. We have completeness. Next step, let's talk about purity. A domain model is pure when it doesn't have out-of-process dependency. A domain model class needs to depend only on primitives or other domain classes. So, now let's imagine another requirement. We need to check for username uniqueness when we update the username. If we want to keep the model complete, we need to slot uniqueness check in the user entity class itself. But as you can notice, we introduce a dependency on the user repository, which ultimately represents the database, which is an out-of-process dependency. Our model is not pure. If we want our model to be pure, we need to move the uniqueness check to some other layer of the application. It could be the controller layer. In this case, we're creating a user controller that checks for username uniqueness. Now the model is pure, but it's not complete because we spread business logic between two layers. Vladimir proposes another option that is pure and complete at the same time. We can load all users in the user controller and we can pass that data to the update username method. As you can see now, the user entity has all the business logic in it, so it's complete again. So we have purity and completeness. Problem solved, you might think. On the other hand, we have introduced a bigger problem, which is performance. This solution would never work in a real-world scenario where we have a large number of users. First of all, they might not fit in memory. And even if we lazy load them, the process of checking for username conflicts one by one is painfully slow. That said, we have demonstrated the trilemma. Vladimir's trilemma states that we can have only two attributes in our system between completeness, purity, and performance. If we want to achieve purity and completeness, we need to move all our database reads to the edges of our application. In our case, that would be the controller layer. Instead, if we want completeness and performance, we need to accept out-of-process dependencies in our domain model. Finally, if we want to achieve purity and performance, we need to be ready to split our business logic between the controller layer and the domain layer. Now that we have these three options, which one should we choose? Vladimir suggests that you should prefer purity and performance over completeness, and that means that you should be ready to split your business logic between the controller and the domain layer. If we stick to the scenario he describes, I agree with Vladimir, and the reason is that I would never give up performance. Even if we don't want to over-engineer a system, we need to future-proof it. If we don't do that, we're buying a one-way ticket to the recycle bin for our code. And if I had to choose between purity and completeness, I prefer purity as well, because completeness would be forcing me to hammer too much code within the domain layer and to introduce those ugly out-of-process dependencies. Now it's time for my conclusion, and as I said, I don't fully agree with Vladimir, and the reason is that in his example, he mentions only controllers and entities. Maybe he did that to keep things simple. Tactical domain-driven design includes other building blocks that we can use to define our domain model. In particular, we can use services. And I'm going to quote the Domain-Driven Design book by Eric Evans. There are cases where the clearest and most pragmatic design includes operations that do not conceptually belong to an object. Rather than forcing the issue, we can follow the natural contours of our problem space and include services in the model. A service is an operation offered as an interface that stands alone in the model, without encapsulating state as entities and value objects do. Services are a common pattern in technical frameworks, but they can also apply to the domain layer. I think we solved our problem. We had moved some business logic from the entity to the controller, but now we can move it back to the domain layer by adopting services. Now we have a model that is pure, complete, and performant. As I highlighted in other videos, we often tend to think that the domain model is just a data model made of entities and value objects. That's not the case. And if you want to know more about the DDD, make sure to see my video where I cover all the DDD concepts in under 10 minutes. The other thing I dislike about Vladimir's solution is the placement of business logic in the controller. That's a big no-no for me. You never place business logic in a controller. The controller's job is to handle users' requests and to act as a bridge between the view and the model. In addition, in an MVC architecture, it's possible to have multiple views and multiple controllers leveraging the same model. And that's very common when you need to support different classes of clients. In this scenario, it's obvious that placing code in the controller layer is not a good choice because it would cause code duplication, and that it actually causes many other issues, so you don't want to do that. I hope my conclusion was fair and clear. I made 2 points. First one, let's use all the building blocks of tactical DDD. We don't have just entities and value objects, there is much more, like services. And the second, never put business logic in the controller layer. I hope you enjoyed the video. I thank you for your time. If you disagree with me, write a comment in the section below, and please share this video with your colleagues so they can all learn something new.